Hello everyone. So in today's lecture we are going to see why Java is called as the platform independent language. Okay? So, if any programming language allows its application to compile and to execute on the same operating system, then that programming language is called as the platform dependent programming language. Okay? And the example is what? We have few examples like C and C++. Okay, see the definition. If any programming language allows its applications to compile and execute on the same operating system, then that programming language is called as the platform dependent programming language. For example, C and C++ applications. Okay, so let's see in detail. Let's see by the help of example. Okay, so before that I would just like to tell you a few things like first you should know about compiling and linking process. It is a process in C. Okay, so let's see little bit. So what do you mean by compiling? The modified source code is compiled into binary object code, but this code is not yet executable. Okay, this is what compiling. This is what in compiling phase. Okay, and during the linking phase, the object code is combined with required supporting code to make an executable code. Okay, this step involves adding in any libraries that are required. Okay, so let's see. So here we have this what an an machine with the Windows operating system. Okay, so here the source file is what? Here the source file is what? abc dot Okay, so basically here this is what? A source file which is written in C language on Windows operating system. Okay, and this file is called as source code because it is written by the programmer, right? So during the compilation phase, this abc.c file will compiled into what? Will compiled into abc.obj file, which is what? A binary object code. This is what? A binary object code. So this is what? This is also known as what? Compiled code. Okay, and this phase is what? This phase is called as what? Compilation phase. This phase is called as what? Compilation phase. Fine with this? Things are clear up to this? Now, so see, as it is compiled by the help of Windows compiler, the abc.obj file is now what? Windows dependent object code. Or you can say that this compiled code is now in Windows understandable format, but this is not yet executable. You have to make it executable. Okay, but it is already converted to the ML, Windows machine language. Okay, it is already converted during the compilation phase itself. Okay, so let's see now. Now the execution phase starts. Now which phase start? Execution phase. Execution phase starts. So now the execution phase starts. Here we have a Windows linker. What we have? We have Windows linker. This Windows linker will take this object code, okay, and add on the required libraries and provide you an executable code here. Okay, like this abc.exe it is an executable code which runs on the Windows OS. Okay, So here the operating system is Windows. That is the reason you got abc.exe, which can only executable on Windows platform directly. Okay, is this fine? And you will get the output after executing this executable code. So this is what a basic flow. This is what a basic flow that is in what C programming language. Fine. So in the next case, we have what Linux operating system. In the next case, we have Linux operating system. Therefore, the executable, therefore abc.c. Therefore, the executable file which is generated in this case is what abc.bin. Okay, which can only run on Linux, not on Windows. I mean, this is Linux OS understandable format. So here, these C compilers are what are OS dependent, which generates OS specific, which generates what OX specifics. Hold on, Linux ML, which generates OS specific machine language. And as compiler is a part of C software, therefore C is also platform dependent. Same story goes for C++ also. Okay, hope you understand. Here C compiler is operating system dependent, which generates OS specific machine language, and as compiler is the part of C software, therefore C is also a platform, what platform dependent, not platform independent. It is platform dependent. By mistake I have put in. Okay, consider this one. So hope you understand. See, in the case of Windows, here we were using what Windows compiler, and this code was only understandable by the Windows. That was what Windows machine language. But in this case, as I am using the Linux OS, so this code is what Linux machine language. So compiler will give you what Linux machine language code. Okay, that is the reason I'm saying that you're changing the compiler for every OS. That is the reason the C compiler is what operating system dependent, means C compiler for Windows and C compiler for Linux. So, and it also generates what OS specific machine language, like you see here. Fine. And as compiler is also a part of what C software, therefore C is also what platform dependent. C is also what platform dependent. So in this case, as you noticed here, that the ML generation, the ML means machine language generation, happened during which phase? During compilation phase, not during execution phase. So if we move ML generation from compilation phase to execution phase, then we can achieve platform independency, because client OS is known only at the time of execution in server client architecture. Okay, let's see the next. So Java achieved platform independency by moving machine language generation from compilation phase to execution phase by introducing what bytecodes and JVM. See, James Gosling and his team invented a new format code called bytecode, which is generated by the compiler and a translator software called JVM, to translate it into machine language of the current client OS. This time what is happening? The compiler is responsible to convert your source code to bytecode, not to directly machine language. Okay. In this case, it is converting first to bytecode, and the JVM is responsible to execute this bytecode and provide you a machine language code. Okay. Who is responsible? JVM is responsible. So see, you can say bytecodes is an intermediate format that can only be understandable by JVM. Okay, and JVM is what a software that executes Java bytecodes by converting bytes code into machine language of the current operating system understandable format. I hope this much is clear to you. Fine. Now let's see. So Java achieved platform independency by moving machine language generation from compilation phase to execution phase by introducing bytecodes and JVM. That's what we discussed. We will see this, don't worry. Now let's see what happened in Java. I have written one program, that is what, test.java. I have written one program, so this is what, a source code for me. This is what, a source code, okay? And the file you have to save like test.java, .java extension. So this is what, a source code in Java. Okay, so here the source code file is what, test.java. .java extension file is called as source code, which is written by the programmer. Now, now see, after compilation, you will get test dot class file. So this dot class file is called as what, compiled code. Compiled compiled code, okay, which contains what, which contains byte code, which contain byte code, which is generated by the compiler from source code. Okay, this much is clear. So the dot class file, this dot class file is not at all platform dependent. This bytecode is generated by Java compiler, okay, and is only understandable by JVM. So JVM is now responsible to execute this bytecodes. So JVM will execute this bytecodes, and what it will do, and it will convert them into the machine language of the current operating system, into the machine language of the current operating system. Okay. So who is responsible here? JVM is responsible. In the C, who was responsible? Compiler was responsible to convert to machine language of current operating system. But here the case is different. Here compiler is responsible to convert the source code into the bytecode, and then JVM is responsible to convert this bytecode into the machine language of uh, current operating system. Okay. Here Java compiler is what, OS independent. Because why? Because see, it takes what, it takes Java source code as input and generates Java bytecode as output. Here both input and output, both this input and this output is what, output files are Java related files. That's why I'm saying it is what an OS independent. But JVM is OS dependent. JVM is what, OS dependent, because it takes Java bytecode and generates what, OS dependent machine language. For example, in this case, suppose I have the OS operating system Windows. So this JVM will convert this bytecode into the what, into Windows understandable machine language. Okay. And if it is Linux, then it will convert into what, Linux understandable format, right? So this is what we called as, here see, here Java compiler is OS independent because it takes Java source code as input and generates Java bytecode as output. Here both input and output files are what, Java related files. But JVM is what, OS dependent, because it takes Java bytecode and generates OS dependent machine language. Fine with this? So the Java program is what, platform independent. But that is the reason Java program is platform independent, but Java softwares are platform dependent, because JVM is platform dependent and is available for every OS separately. You may have heard that JVM for Windows, JVM for Linux, JVM for Solaris. Okay, so we have the JVM for every operating system separately, right? Now let's see one example over here. So this is what, tell me one thing, test just Java. this is what Java compiler, and after compilation it becomes test dot class. So this phase is what compilation phase. I'm right. This phase is what compilation phase. Compilation phase. Okay, and this phase is what? This phase is what? Execution phase. Okay, execution phase. So developer is only responsible person who used to develop, compile, and execute the Java application. So for them, what is required? JVM and compiler both are required, right? Whereas client is only responsible for executing that application. Therefore, for client, what is required? Only JVM is required. That means only JRE is required. Okay. So compilation phase here. This compilation phase is what? Platform independent. Independent. Okay. And execution phase is what? Platform dependent, right? Platform independent. Sorry, dependent. As you can see here, see test.java you have written, after compilation it becomes test.class. So is this phase is platform dependent or independent? It is independent. We have already learned this, why it is platform independent, because during the compilation phase it is taking the Java file as an input, and the output is also what? Java file itself, means Java bytecode file, right? So it is purely what? Platform independent. But when during the execution phase, you have this test.class file. So this test.class file, suppose you are using which operating system? Windows. So you have to download JVM for Windows, then only this test.class file will execute, and it will execute on the JVM, and JVM will generate what? Windows machine language. It will generate Windows machine language, and then only you will get what? Output. And suppose in the case of Linux, you have to download the Linux JVM, means JRE for Linux. And after that, you will get what? JVM generates what? Linux machine language, and then you will get the output. So see, this phase, the execution phase, you are changing your JVM according to your operating system, right? That's why the execution phase is what? Platform dependent. But the compilation phase is what? Platform independent. And developer work is what? Developer work is to compile and execute the Java application. So basically after compilation, this is ready. Your application is ready. Now as per the requirement, you can execute this on Windows also. You can execute this on Linux also. If you are executing on Windows, if you want to execute on Windows, then you have to download JVM for Windows. And if you want to execute on Linux operating system, you have to download Linux JVM, that is JRE for Linux, right? So this is a small explanation. So that's all about Java platform independent nature. So thanks for your valuable time. Please subscribe our channel for further updates.